nCode here. Today we're going to be talking about what happens when we're overwhelmed by data or too much data. We're going to see some challenges and some solutions for different ways to be able to handle all the data that we're supplied with and we're able to collect today. And so let's go ahead and take a look here at our agenda. We're going to start off and look at the different challenges engineers and corporations and data collectors and requesters of data we face on a daily basis. Right, then what we're going to do is look at what are the solutions and how can those be addressed. We'll then go into a live demonstration and then some questions and answers. So let's start off and look at the different types of data that we have out there. So a lot of our customers are collecting data from a lab environment, some from field testing, customer usage, computer-aided engineering, and also documentation. So in the past, we really just focused on the squiggly lines and the types of data that GlyphWorks and DesignLife are really good at handling. So the simulation data and the collected data. But it's also important for us to look at other pieces of information like photographs and videos and different documents. So those are the types of things that we have coming into us in this day and age. So lots of types and sources of data. The question is, how do we manage all of this data? All right, so what are some of the challenges we have with all that? All right, well, because technology is improving, that means our hardware capacity is growing. We have more channels and things like that. So the volume of data is increasing. In the past, when I collected data years ago, we would typically look at 10 to 50 channels, maybe up to 100. But companies now are collecting 100 to 5,000 channels in a data acquisition. So that's a lot of data to sift through. So there's more types of information also, not just the channels. Like we said, there's photos, videos, documents, reports, those types of things that need to come along with that information. And we need to be able to find that information and do something with it. So we need ultimately a better way to manage all of this information. So let's start off on a challenge here. One of the typical questions for people is, where's the data? So if a data acquisition happens, and this was the case for me years ago, we would do the data acquisition, and then people were wondering, where's the data go? Where do I find it? Sometimes it sat in people's desks. I remember one case where I had to look for data that someone else had collected, and unfortunately it was in their desk drawer and they were on vacation for a week. So I had to wait a week for them to come back. So where's the data? It could be in CDs, it could be in folders, it could be in a mezzanine upstairs somewhere where data is stored away in a filing system, right? But ultimately, we find out that most of our customers, before they're customers of automation, are saying, we waste too much time looking for data. So I know in the case when I used to collect data, I probably spent about 40% of my time looking for other people's data or also delivering data to those people. So what is the solution for this? Automation consolidates and organizes data into one location. Here's a screenshot of the automation data tree where we've got all of our areas and a structure set up in such a fashion that we can easily find our data. The important thing is automation is a web-based tool where all the collected and stored and analyzed data is actually maintained. One single location. Because it's in one location, we can also utilize the search feature of automation to look for things like data, documents, and any metadata or information about your data. That is also searchable. So let's take a look at another challenge here. Another challenge is maybe an engineer who is the collector of the data or the data owner. So they might say something like, I'm overwhelmed when people come to me each time they want data. Again, this was me for a while back in my past, and people had to come to me and they had to ask for data, and I spent probably about 40% of my time finding data from old data acquisitions, converting it into a new format, and providing it to them. On the flip side, if I'm an end user of that data, let's say I'm an analyst or a testing person, I need that data that somebody else collected. If I have to go back to the original collector of that data, I could be sitting there for a long time, especially if that guy's on vacation or he's busy with other projects. So ultimately, I want that data and I don't want to have to wait for the guy who collected it. The solution we have for that is automation. When data owners or the collectors get their data, they can upload that into automation. Again, because automation is a web-based system, the data requesters, people who want the data, they can get their data directly from automation whenever they want and wherever they want. So many of our customers have data that's collected in the United States, and they might need to have somebody in Australia or Europe be able to go ahead and download that data and look at the results. Automation allows that. Let's take a look at another challenge. So a lot of times, because we have the increased capacity to handle a lot more channels, maybe up to 5,000 channels, this is a lot of data. When we look at it, product or release engineers or analysts are typically used to looking for a subset of that channel count. So instead of having all 5,000 channels, maybe they only want the engine channels or GPS channels. Or maybe if they're in a front suspension group or a frame group, they might want to choose just the channels that are pertinent to them. They ultimately say, I don't want data that I don't need. So how does an engineer get just the channels they want? That is the question. Using automation, engineers can select only the channels that they care about and disregard everything else. So in this case, with this screen, if I'm an engine analyst, I can just pull the data channels that I care about. In this case, engine loads and temperatures and speeds, those types of things. Now I only have a subset of data that I'm analyzing, and I don't have to worry about all the other channels of data that other people have collected. Let's take a look at another challenge. Stored data can be hard to interact with. We all know what it's like, where if typically we have our data and we collect it, and let's say our IT gets a hold of it and they put it on a hard drive somewhere. Well, number one, it's hard to find, and we've already talked about that solution. But sometimes it's hard to interact with, because then we're forced to download that data, move it into new folders, and then pull it down and open it up in Excel or some other format file software. But ultimately, we don't want that. We want an easier solution. How can I easily interact with that data? Typical things people would like to see are the plots of the data, results, that's important, statistics, max, mins, that sort of thing, reports, photographs, maybe some videos, and any other documentation that went with that project. It's easy to think of a project when it's actually collected, but when you go a few years down the road and you want to look back at that data, that's when it becomes hard to find and also interact with that data. So the solution, again, is automation. Using the data tree, we can easily look through and find that data, or the search mechanisms we showed a few screens ago. But while we go through automation, again, which is a web-based system, and you don't require any other software on your computer other than a web browser, these are the types of things you can do to interact with that data that was being collected. So you can take a look here at statistics, data plots, so you can go through all your different channels of interest, and also any attachments. Again, these could be any other types of files that would go along with a logbook, like photographs or videos, any other types of documents or reports. So automation gives users direct access to these requests. And again, the nice thing just to keep in mind is if the person who collected that data has left the company or is on vacation, it doesn't matter. This information is all available and stored inside of automation. So that was a good solution. Now, what about if all I care about are the answers? I don't want to go back and recalculate numbers and results. I don't want to download data. I don't want to go and run things through Excel. I just want to look at results. And maybe in this case, I want to look at results for the last 3 years of a given vehicle or component. What is my solution for that? Well, automation allows you to upload data, and while the upload happens, you can choose what set of processing happens to that data. In a lot of cases, customers of ours have GlyphWorks processes that they've set up. And what they want those GlyphWorks processes to do is to reduce that data or come up with answers. So basically, when files are uploaded, they can be processed automatically. Because those files are processed automatically on upload, the answers are calculated and stored for each data file. We can see here on the screen, the picture at the bottom shows us a typical event that had been collected, and it's showing us some information or stored answers like maximum engine temperature or RMS acceleration. These are the results that someone might want to look at rather than having to go back and recalculate those. So, because we're able to upload the data and because it's able to calculate the values, that means that individual files give us answers. All right, we've got the original data files, and once we have those and the answers are calculated, automation allows us to compare answers and see trends. We can see here in the screenshot that we've got what's called a matrix report. It's a set of queries or searches in the tool in automation. And it allows us to go and look at the different vehicles that were collected among the different years that that data was collected. And it shows us the summary results. In this case, things like what was the total distance of the vehicle, or what was my average fuel economy, or in the case of an engine, what was my average engine temperature, that type of thing. It allows us to see all the different trends of that data by looking at results rather than having to download that data and run through that processing manually. What that can mean in terms of benefits is someone who might want to do this analysis by looking at 3 years worth of data, if they're doing it manually, it might take them upwards of 1 to 2 weeks to get this information, depending on how much time they have set aside each day to do it. With automation, they can turn around a report like this within a matter of minutes. So let's go ahead and take a look at a live demonstration system. So here's a live demonstration system I've got running here locally. And you can see over on the left-hand side, there's a data tree. And this shows us kind of the hierarchy of all the data we've got from my existing system. And I do have quite a bit of data for some field testing data, as well as some lab testing data. This happens to be some component information and full vehicle. If we take a look here at the components, we have a particular component or a project called G600, and it's got a number of years of data collected for it, ranging from the year 2010 till 2013. So this is our data tree, and going through that data tree, we're allowed to do a number of things. Some of those things include looking at these little paper clips. This paper clip, if I just click on it, it shows me now an attachment or another data file that was associated with that project. Imagine it's like a logbook of sorts. So here's a record of that particular Excel file, which we can then click on, and it allows us to open that directly. Why is that an advantage? Well, I didn't have to go separately and download that file or search through a logbook. I just simply looked through automation to see which things were associated with that project. In this case, the engineer chose to upload this channel list. As we look down at other areas down below, there's another paper clip next to an event level. In this case, the engineer chose to put a picture and also a PDF file. So there's no limit to the number of attachments or other supplementary data that can go with your project. The advantage here is that it's all stored in one location. Not only is it stored in that one location, but it's also searchable. So if you look at the top of the automation screen, there's a search icon. We can click that, and what it allows us to do is it allows us to search through the entire system and look for things like objects or data or attachments. These attachments were those things we saw, the paper clips. So we could do a search down here for something like G600. All right, so that's our particular project. And let's say that we want to only look for attachments or any related documents with that G600. Once we run the search, it then comes back and it shows us any documents that were associated with that. All right, so that's the search ability. Now we'll also see here, we've got some data files. Each one of these red looking things next to the event level, that is an actual data event. We can click on that And once we do that, we look over on the right-hand side, and there's a section up here called View Characteristic Values. What that really means is look at calculated answers, something that GlyphWorks calculated when that file was uploaded. Here we see RMS acceleration, engine temperature, some maximum engine speed, and some damage severity. So these are some pieces of information that I, as an engineer, am very interested in, and I want to track that in every single file that's uploaded. So I could get this information by going to each of those areas. All right, so that's some statistical information. We also may want to look at just plots of that data. Now again, I don't have necessarily GlyphWorks installed on my computer or any other nCode products, but I do have this web browser, so I'm able to do things with this web browser like look at the channel data. The way I'll do that is I'll right-click on this base time series object, and it's going to come up with a menu. It gives me some different functions of things I can do on that data. In this case, I just want to use this bottom option called View Data. Now once we do that, it actually goes through and it pulls images of just that particular file. So we've got all the different data images. All right, we can click on those images as well, and it's a time trace of these channels. This one happens to be a CG Excel in the Z direction. All right. This may be a channel of interest to me, but what I'm able to do here is interact with that data and see what it is before I download it or do any other analysis with it. All right, so that's some of the interactivity I can do with the data in the data tree. Now we talked about another challenge and solution. You can see over here with these thumbnails, we're actually looking at, it turns out to be 13 data channels. You can imagine as some people collect data, and like I said earlier, they might collect up to 5,000 channels. Nobody in their right mind who's looking at a certain subset of channels wants to look at all of those channels. So they want the ability to download just that subset. One of the ways they can do that is by going in the data tree and right-clicking and using the option called Advanced Download. When we do this, we're presented with the ability to select which channels of that file do we actually want. This is one of the unique advantages of automation. So we can choose all channels, or we can choose a channel group that has been pre-set up. In this case, I've pre-set up 2 different channel groups, one for engine and one for GPS. Or most people will use this third option called Pick List. Pick List gives you a listing of all the channels that are available inside that particular project. And you can then go through and select the channels of interest that you would like to download. This is a big advantage, again, for the analyst who doesn't want to sift through hundreds of other channels that other people, other engineers need. In this case, all I care about is the engine channels. I can then go forward in my process by clicking the next button at the top, and that'll take me through a wizard that allows me to download that data. But again, it's only the channels I care about. So we've taken a look at how we can look at data and interact with it through the data tree. We've looked at how we can download that data as well. And what I'd like to do next is, how do we actually look at the results of that data? Now we saw one way by just clicking on an event in the data tree and looking at its characteristic values, or statistics rather. Now if I want to go through and I want to look at the RMS acceleration or my engine temperature, and I want to compare my engine temperature across this particular project, let's say for 3 or 4 years, and see how it's changed over time, I want an easy way to do that. What I want to avoid is downloading any data and using Excel to put all the values together so I can make plots. Sure, that's a way that will work, but automation has a tool inside of it that allows us to quickly and easily navigate and organize that data. The name of that tool is actually called Query Templates. So it's an advanced search of sorts. So we started off in the live demonstration by showing a basic free text search where we can type in information like what was the name of the project we want to look for. A query template allows us to go a little bit deeper. It says, what do we want to find and what do we want to return? What type of information and how do we want that organized? So what we're going to do here is we're going to click on Query Templates, and this comes up with a set of queries over on the right-hand side. In this case, I've created a query called compare engine temperature versus year. So we can see here for this given project in the data tree, it's called G600, it's got 4 years worth of data, 2010 through 2013. So all we're going to do right now is we're going to go ahead and run this query template. The first thing it asks us is which model do we want to look at? It might be G600, or it might be an M157, or whatever we choose to look for. But in this case here, we're going to look for G600. All right, so we click the next button, and it takes us through, and it actually gives us a report now. The values that we see in this report are the same as if I were to go to every single data event in that data tree and manually pull out the values. This is just organized and sorted all of the results from all my different years. So if we take a look here, we've got 2010, and here's all the data files that came with 2010. All right, and it's got things like what was my RMS acceleration, also what was my maximum engine temperature. So in this case, you can see here, it's also highlighted in the gray section at the header for each year, what was my minimum, maximum, and average engine temperatures. We can take a look here and also see that there's some orange highlighting going on. I've chosen in my query to highlight anything over a certain value for temperature, and I wanted that to be highlighted so it's visible to me as an engineer. So here we go. We've got data for 2010, 2011, 2012, and now I can kind of quickly start to put these values together and see how my temperatures have changed over time for a given component. If we scroll down, I've also chosen to use a plot or a chart based on the information that was returned in the table above. This particular chart is just using the numbers from the table above and putting it in a graphical representation. What I can see from this now, relatively easy, is that going from 2010 to 2012, my average engine temperature has actually decreased. So that means maybe I'm doing a good job, or our group is doing a good job in increasing the coolant flow, or maybe that's the result, or maybe we're actually working the vehicles less difficult or less hard. But essentially, we can go and do some training to see how is the performance of a vehicle performing, or a component. This particular chart is showing 3 different elements. It's showing the average, maximum, and minimum values for engine temperature over those 3 years. Again, it's the same type of information we could have gotten by downloading that data, running it through GlyphWorks or Excel or MATLAB, and then using Excel to plot that type of information. So it's a quick way for us to do this analysis by just using a query and the fact that the results are already calculated for us in automation. The last thing I'd like to show in the live demonstration is what's called a matrix report. If we look over on the left-hand side here, there's an area called report templates. And this is another tool for us. And we've got one down here on the lower right. It's called Webinar Main. And by clicking on that, it's actually going out through the entire data tree at all the data we've collected so far. And I've chosen, in this case, to organize it in a fashion that shows me my testing method. So like field testing or lab testing, we're looking at that compared to the year. So in this case, I can see my field testing for 2012 has had the highest average engine temperature. These types of reports can be expanded such that you click on different values and it'll do a drill down report, so you can do more advanced queries. All right. Again, the ultimate thing here is that, number one, your data is safe. It's in a consistent location over here in the data tree. People can find it. You can also have it automatically calculate results, and then it's easy for you to get those results and do some comparisons with it. All right, so that ends our live demonstration part. Let's just go ahead and touch on the benefits of these different challenges and solutions. Automation allows us to find the right data. We've got a search tool, and we've got the ability to have a data tree that organizes that data in a nice fashion. We can get data when we want it. If I'm an engineer and I don't want to wait for somebody else to get back, or if I have to supply data to somebody else, I don't want my phone ringing off the hook. Automation is a good collaboration utility that allows that to happen. I can get only the data I want. So instead of getting 5,000 channels every time I look at data, I can look at just the subset of channels I care about. I can also easily review that data just using a web browser, looking at channel statistics or plots. And ultimately, I can get my results, not just the data. So find me plots and charts and things that might normally take me hours to do, I can do in minutes.